Why, hello and welcome to my lab. It's been a while and much has happened. I got a new job, we reorganized some of the lab here, and as usual we got some new tools, like this conspicuous beastie here. This has been a real life changer because I didn't even really have a proper drill press, and now we can we can make very accurate parts in metal and put holes wherever I darn well please to put them. So I've spent some time practicing on this and I'm quite comfortable with it now. And so that's giving me the usual itch to make something. And I think I have a bit of an idea. So follow me. You see this whiteboard? I don't use this whiteboard as much as I would like. And that, quite frankly, is because my handwriting is not good enough.
Draw a dog.
A dog?
Yeah. Dog head. And see, I do actually have questions. Like.
it's a dog. Let's just, for the sake of the math, let's assume this dog is a right circular cylinder. Let's just pretend that didn't happen. Yeah. So, anyway, so I'm going to solve this the same way I solve every problem. I'm going to build a robot to do it for me. So what I'm envisioning is a rail up here and down there with a big vertical carriage to hold this small marker. And we'll test out several different ideas that I want to test out, which is the real purpose of any silly project. There's several different things I want to try out, like whether or not the dirt cheap rail on Amazon is any good. And I actually have some here. But this stuff actually seems surprisingly good. I mean, it's really cheap, but I mean, I'll really have to put it through its paces to tell if it's good, but it doesn't feel chunky or anything, so. These will be the long horizontal rails, and then there'll be a carriage that rides on these that will then mount these vertical rails. And I'm trying one set of this circular rail and one set of this standard linear rail, at least standard from my perspective. One of the main motivations behind this is to test the CNC controller that I want to use eventually for the milling machine. That milling machine isn't going to stay manual for very long. I'm going to do a CNC retrofit on it. And I've got my eye on a certain CNC controller. One that could possibly be expanded to do 5 axes, which of course I can't resist. So this one is going to use a 4-axis version. Of course I'm only going to be using 2, but this should be a good test to see if I like the system as a whole. And then we'll also try out some other random concepts that I want to try out along the way. So there's a good chance of failure, which is exactly my favorite kind of project. We'll go ahead and look at the CAD as I'm building it, and let's just kind of get to it. And as usual, the first thing to do is to take large chunks of metal and turn them into smaller chunks of metal. I've already marked out rough positions for the various different parts, and they're labeled with the sheet number for the given part. So I'm going to go ahead and I'll verify these lines really quick, and then I'm going to rough them out on the bandsaw, and once we've got all the parts roughed out, I can take it to the mill and square them up and get them the right dimension before going any further. So let's get started on that. All right, so now that all the rough stock is cut, it's time to square up all the edges and then bring it into final dimension, at least for this block before we start cutting the rest of the features. If you want to know more about squaring stock, it's probably better that you just search squaring stock, because then much more experienced machinists than I will teach you how to do that. Probably better to learn from them than from me. But anyway, you can already tell that I've tried some from the chips here, and that worked out really well. So I'm just going to go ahead and square up all of these, and then we'll get to the more interesting part. Okay. Well, with all the tedious work done, we can now start to strategize about how this is going to go down. Let's look over here. Okay, so actually assembling this on the wall might be a bit tricky. So I think what we'll do is line up the first horizontal rail up there and just get it level and basically in the right position, and then assemble the vertical carriage so that we can use the carriage to make sure that the lower rail is actually leveled correctly. That should work well enough for this application anyway. Usually you would do a lot to make sure that's exactly in the right position, but here it doesn't really matter. So I think I'm just going to make the components as we assemble it, and that way it'll be a lot more interesting. And I can make sure that everything's going to fit before I make everything and then realize that some small detail is wrong. So let's just start with making this part here. I'm going to call this part the lower horizontal carriage block. Of course, there's an upper carriage block as well. Mostly this thing is just going to be full of tapped holes to mount everything else. So essentially it's going to be a hub for all the other parts that we're going to make. I'm just grabbing the center of the block here using this device. You can Google Edge Finder if you were curious about this thing. Okay, the first holes that I need to drill are going to be for the horizontal carriage blocks. So these are going to be clearance holes, but there's also going to be a counterbore. In order to do the counterbore, I'm just going to use a drill bit because that's going to be close enough. So to get a counterbore that's a specific depth, I'm going to lower the quill into a locked position and then raise the knee until it starts cutting. Then I can set that to 0 in my DRO. And then I can raise the knee to give me, in this case, 10 millimeters. Now, when my quill reaches the end stop, then I will have 10 millimeters deep of a hole. Now these holes that I'm producing now are going to be for a block that is actually going to mount to the horizontal belt. I don't think that's going to make too much sense now, but you'll see that later in the development. And then these 4 holes are going to be M4 tapped for the linear rail. There's also these M4 holes here, which will be part of the motor mount that you'll see later. And man, is power tapping so much better than trying to do it by hand. These taps have an angle at the bottom, which pushes chips through the hole rather than just collecting them in the flutes. Then I'm going to put in some M6 holes, which will be the mount for the ball screw. I also power tapped those, but that's pretty much more of the same, so I'll just skip that. So that's that face done. As soon as I clean it up, we can move on to the holes that I need to put into the ends. And then these holes here will be for also that same motor mount that I referred to earlier. There's also some smaller holes to the side, which are actually going to hold the cable carrier. And I just kept using that same trick where I would lock the quill at the lowest point and then use the knee in order to set the depth that I wanted. And then these taps are also really cool. Instead of pushing the chips down into the hole, they take them up out of the hole. And that way you can just tap holes that don't go all the way through. With that side done, there's only one more thing to do. And I'm going to add just a couple more M4s on the opposite side. And these holes are going to mount a tool that I will use to place the plates that are going to go on the wall. That'll make more sense when we get to it in a different episode. The other parts that I need to make first are actually very similar to this, so I'm just going to show you what I made. First of all, of course, I'm going to make the upper horizontal carriage block. It's very similar, some holes in different places. Then of course I'm going to make the vertical carriage block as well. And with those, that'll allow me to assemble all the basic structure. Now that these pieces are complete, we can move on to the next step. I've already attached the horizontal blocks here to both sides. And I'm going to just pre-assemble the carriage, and then we'll get one of these rails up on the top to the correct height and level, and then we'll use the carriage as to define the correct space for the lower rail. So I'm just going to get started by assembling the carriage here. And the way that we have to assemble this carriage is going to be a little bit particular because I'm using everything to square everything else. So I've already got these on, so that's our first reference. I'll take our linear rail, should be around there. So I can loosely tighten down this end, and that gives me 1 point of reference. Not too tight, that way it allows it to both move this way and rotate. And then I can come over here and get this one lined up. Okay, so now we're locked down on 2 points. So I'll grab the other one. All right. And of course, as things get added, everything gets easier and easier to line up because we're closer. because of the other references. It'll naturally be square-ish because it was defined to be. All right, so I'll grab the ball screw. I've already got the nut and the mount block here. And once again, I'm just going to tighten down one of the corners. And by tighten, I mean very loosely, just enough to hold it in place. So this still has some wiggle in it. So now, I already made these spacers off camera because they're pretty basic. That'll give us just enough height for this guy to get over the ball screw. So at some point I just have to tighten something down, and I think that's going to be this plate here. I'll get this as square and center as practically possible, and then I will use that as the reference by which to square everything else. So normally you would spend a bit more time squaring this up. You'd be using dial indicators and getting it really straight, but with the application that we're doing, just drawing on a whiteboard, it really doesn't matter enough for me to bother, especially because we're attaching this to just a wooden wall, so it's all going to be pretty floppy. Okay, so now that's tightened down. Okay, and then here's another block I made off camera, and this just attaches the carriage. Okay, so now I'll just use the drill to get the carriage in position gently. Okay, so now that it's over here, it's going to be constraining the linear rails as well as this ball screw. So I'm going to go ahead and define that as correct and tighten them down. Okay. Just enough to make sure it doesn't wobble anymore, but allows a little bit of rotation. And then I can take it to the other side. Thankfully, the servo motors are going to be a lot faster. Now that the angle is good, I'm going to go ahead and finish this side. And the reason that works is because I know the spacing was good when it was over here. Tighten these two down so they don't move, but they can still rotate if you run the axis down. And now that means these are going to be good enough in terms of their rotation. So I will finish screwing those on. And then I'll finish this side. And now that actually all of this is locked down, I'm going to probably take the ball screw off just to make it lighter so it's easier to handle when I'm trying to lift it up. And now we have nothing but the spacer. This is going to be much easier to handle in the next operation. Yeah, it's not too bad to lift. So I measured where we need it. I defined it very conveniently to need to be right at the bottom of this board and about there. It can move a little bit left and right, so I'm going to try to actually line this up with one of the studs in the wall, and we'll go from there. Right there. Okay, you can take this down. All right, bring it back, bring it back. Oh yeah. Okay. Now if you let go, is that gonna drop?
Yes.
Good. Okay, don't do that. I'll be right back. I don't need these. There you go. Have a ladder.
Thank you. This is exactly what I wanted.
I'm gonna put that there.
Well, heck.
Oh man, this feels comfortable.
I don't think so.
I'm lying to you.
He's good.
Yep, you can let go. Oh, perfect. At least to the accuracy of this level. Okay. We'll probably do the rest off camera because it's just going to be, I'm going to actually start cutting holes in the aluminum where the studs are and make sure that I'm tapped into every stud, put 2 screws in every stud, and I guess that's just going to be as good as it gets. There we go, that works surprisingly well. Now, it's time to put the axis, the carriage on. Oh no, not the haggling. I mean, heckling. That's a different thing.
So
Oh,
only 15 cents.
there we go. Nice. It's still straight enough to roll. I think that'll work. Okay, so in case it didn't make sense before, I'm going to use this to define the spacing for the bottom bar. Okay, let's do that. Ooh, there we go. I think that's it. There's, I don't know if you can hear me, but there's a variable resistance I feel on this thing, and normally that would not be acceptable, but I think given the silly thing I'm doing, attaching rails to wood, that's probably as good as it's going to get. I think that's going to be good enough. This is a good start. Now we can just keep building out the components and adding them on until we've added them all and it works. So I'm kind of surprised actually how well this turned out with the wood kind of wobbles. I don't know if you can see that, but it's a little bit wobbly as I go across. So we'll probably have to reduce the speed that we would have had in the end. Of course, with the servos that I'm going to add, this thing could whip across and probably shake the whole building. So we'll have to slow that down a bit to not do that. We'll probably try it once though. But anyway, I think that's good for this episode, so we'll see you next time, and thank you for watching. Haven't I been embarrassed enough? Why do you have to go try to one-up me on my...
You on your stupid can dog.
Can...
You can open up a can of dog on your boy.
Oh.